Okay, there's the formula you use. NRC2, which is that yellow book, recommendation 4.1. They ask you to do a correction on the homozygotes, right? Instead of just using p squared, which is Hardy-Weinberg's, they're telling you to say p squared and then add that thing to the right of it, which is just p, which is the allele frequency for that locus that you're looking at, times 1 minus the allele frequency times 0.01, right? So try it. Say your allele frequency is 0.3. What's 0.3 squared is what? 0.09 plus 0.3 times 0.7 is what? 0.21. What's 0.21 times 0.01? Just shift the decimal place. And add that to 0.09. What do you get? 0.092. Right? Is that much different than 0.09? So, with common alleles, it doesn't change them much. Right? So that if you have common alleles and you add this correction factor for population stratification or population inbreeding, which could lead to a departure in Hardy-Weinberg equilibrium, if it existed, for common alleles, it's not going to change it much at all. Right? Why don't we correct heterozygotes? When you have inbreeding, you're increasing homozygosity. Okay? So what they're trying to do is they're saying, well, if there is inbreeding, you want to correct so that you're making the homozygotes more common, right? To account for possible inbreeding. So what they're saying is your population numbers that you're calculating aren't accounting for inbreeding. So they're too rare. So you got to make your homozygotes more common to be more reflective if there was inbreeding. You see that? You're increasing the frequency of the homozygotes as if there was 1% inbreeding. Your heterozygotes, if there was, are going to be an overstatement of what they should be.